Okay, everyone, today we're going to talk about solving exponential equations. And the first example I have is a problem that we've seen in the past, but I just want to remind you that there is a particular case when you're solving exponential equations that all you need to do is change the base in order to solve the equation. In other words, for this particular problem, notice that 3 and 1 over 81 are both powers of 3. So we can leave the left-hand side as 3 to the 5 minus x. And we just change the 181st into 3 to the negative 4th. And then that would, of course, be to the x minus 8 power. Then on the right-hand side, all we need to do is distribute that negative 4, and we get 3 to the negative 4x plus 32. Now, since the bases are the same and we only have one term on each side of the equations, this is obvious that the powers must be the same. So we just can write 5 minus x equal negative 4x plus 32. Now, when we plug, put the x's on one side and the constants on the other, solve for x, I'm going to kind of cut to the chase here, we get x equal 9. So the solution to this equation is 9. If we plug it into our original equation, we can verify that that indeed does work. Now, that doesn't happen on all exponential equations. For example, here's my next example, and this is a basic example. However, notice 34 is not a power of 5. So we can't use that technique to solve this equation. However, if we just notice, if we translate this into a logarithmic equation using our definition of a logarithm in that equivalency statement we've been talking about, this simply becomes log base 5 of 34 equal x. And notice, since we're solving for x, that is our solution, all right? Now, we could always take that into our calculator to get an approximate answer, but we want to use exact values here. So just doing that one step, we've actually solved for x here. So I just want to show you on the calculator how we can verify that that is true. However, notice on the check, we really don't even need the calculator for this one, because watch what happens. If we plug log base 5 of 34 in for x, we get 5 to the log base 5 of 34 equal 34. And notice this is our inverse property for logs and exponents. So we know that 5 log base 5 of 34 is indeed 34. So 34 equals 34, okay? Now, I just want to show you real quick on the calculator how to type that in on your calculator to check the answers for the more complicated ones. Also, if you go to your calculator and we take and store that log base 5 of 34 in, your log key is underneath the 10 power button. So if you do control there, notice we get the log and we just simply take 5 in for the base, tab over here, and put 34 in for our number, move outside of the parentheses, and store that in for x. And now, notice if we type in 5 to the x, we get 34. So that does indeed work. Okay, next we're going to try a different type of problem. And we're going to complicate this just a little bit more. Notice if we have 7 times e to the 2x equals 63, to get into the situation where we have the base on one side, in other words, this is e to the 2x here, we just simply divide both sides by 7. So we get e to the 2x equal 9. Then once again, just translate this into a logarithmic expression. So when we do this, we get natural log of 9 equal to x. Solving for x, we get natural log of 9 over 2 equal x. There's our answer. Just a couple quick steps. The additional step because we had multiplying by 2 here. So natural log of 9 over 2 equals x is our solution. And to check, once again, we can store that value into our calculator and check to see if that works. Okay, next we have just something a little bit more complicated. So we're going to take this problem, and once again we need to isolate the term with our power in it on one side. So we add 7 to both sides, and we get 6 to the 3x minus 4 equal 2088. And once again, all we need to do is change this to a logarithmic equation, and we get log base 6 of 2088 equal 3x minus 4. And we're simply left with solving for x. So we need to add 4 and then divide by 3. So we end up with log base 6 of 2088. I'm going to put the 4 plus out in front of here so you don't get tempted to add the 4 to the 2088 inside the log. That equals 3x. And then finally, x is equal to 4 plus log base 6 of 2088 divided by 3. And we're done. Once again, check all of these by storing those values into your calculator and typing in the expression and making sure that the original equation ends up being true. Okay, now the next step is a little more complicated, and there's actually 2 different ways to solve this problem. So I'm going to go through both methods. The first method, notice we've got exponential terms on both sides of the equation. So we could write this in terms of a log. Or we could just take common log of both sides, or log base anything of both sides. So for method 1 here, I'm going to show you that we could just take the common log of both sides and then solve for x that way. Okay, so we're going to take the common log of both sides. So we get common log of 7 to the 2x plus 1 equal common log of 3 to the x plus 2. Now, using the power rule, we're going to bring these powers down. That's the reason we took the log of both sides, so we could move the power out in front as a multiplication. So we end up with 2x plus 1, common log 7, equal x plus 2, common log 3. Now we need to use the distributive property to simplify both sides so we can get all the x's on one side by themselves. So we end up with 2x log 7 plus log 7 on the left equal x log 3 plus 2 log 3 on the right. Now we gather like terms on the left and right, making the x terms on the left, the constants on the right. So I'm going to bring this x log 3 and move it over to the left-hand side. So when I do that, I get 2x log 7 minus x log 3. And then similarly, I'm going to take this log 7 and move it to the other side. So I end up with 2 log 3 minus log 7. Then I'm going to do a little bit of cleaning up of my expressions here. First of all, I'm going to factor the x out on the left-hand side. So I end up getting x times 2 log 7 minus log 3. And on the right-hand side, notice I can use the power rule to bring this 2 inside, and then the quotient rule because of the subtraction. So this just simply becomes common log of 9/7. Now I didn't really need to do that, but it makes my equation much easier to deal with the fewer terms I have in that. And notice on the left-hand side I can do something similar. I can take the 2 inside and use the quotient rule again to write this as x times common log of 49/3. And then this is just equal to common log 9/7. Now all I need to do is divide to solve for x. So x equals common log 9/7 divided by common log 49/3. And And that's a relatively easy expression to type into my calculator to check, to make sure that it indeed does work into my original equation here. You always want to make sure that you check it back up here with your original equation. You may have made a mistake when you translated it or took the logs of both sides there. So that's method one for solving this type of an equation. Okay, here's the second way to solve this type of an equation. Now, in this method, I'm just going to call this method 2, I can just translate this into a logarithmic equation, and I can really choose which one of these sides I want to make the base. For our purposes, I'm just going to make the base 7 here, so I'm going to use my left-hand side. So I'm going to say, using my definition of a logarithm, translate this into log base 7 of 3 to the x plus 2 equal to x plus 1. Now notice in this method, we've only got one log expression. So I'm going to use the power rule again here to pull this x plus 2 out front. So I have x plus 2 times log base 7 of 3 equal to x plus 1. Similar to the last problem, I'm going to distribute the x plus 2. So I have x log base 7 of 3 plus 2 log base 7 of 3 equal to x plus 1. Now, in this case, I'm going to collect my x's on the left again and move my constants to the right. So I'm going to take this 2x and move it to the other side of the equation. And I have x log base 7 of 3 minus 2x. And I'm, once again, I need to move this constant 2 log base 7 of 3 to the other side. So this is 1 minus. I'm going to write that as log base 7 of 9, though. So I can take this 2 inside as the power also. So this is log base 7 of 9. It just cleans the equation up a little bit, and in the end, when I'm ready to check this, it's easier to type in instead of the alternate way of expressing that. So on my left-hand side, once again, I'm going to factor out the x, and I'm left with log base 7 of 3 minus 2 equals 1 minus log base 7 of 9. And then all I have to do is divide off this part here to solve for x, and I have x equal 1 minus log base 7 of 9 over log base 7 of 3 minus 2. And that is my solution to this. Now, if you notice, that's a different, the number is written in a different form than the previous problem, or I'm sorry, the previous method that we used. But those two numbers, this 1 minus log base 7 of 9 divided by log base 7 of 3 minus 2 has the same value as this previous one did here. This log base, or I'm sorry, common log of 9/7 divided by common log of 49/3. They're just written in a different form. Remember, using the properties of logarithms, we can come up with equivalent expressions for logs in many different ways. Okay, we've got one more type of exponential equation to look at, and if you notice this one here, it's a trinomial, and it's somewhat in quadratic-like form, because we have e to the 2x minus 8e to the x plus 7. And just remember, e to the 2x is really the same as e to the x squared minus 8e to the x plus 7 equals 0. So it's a quadratic-like equation. And notice this particular one is easily factored because two factors of 7 that add up to -8 would be -7 and -1. So this one factors easily into e to the x minus 1 times e to the x minus 7 equals 0. For our purposes, most of these are going to be factorable. If they weren't, then we would have to complete the square or do some type of quadratic formula solution method. Okay, so we just use our zero product rule now and say that e to the x minus 1 is 0, or e to the x minus 7 equals 0. In this case, e to the x equal 1. Well, obviously here, x x is 0, right? Over here, e to the x equals 7. Let's just put that in our logarithmic form. So that means natural log of 7 equal x. So our two solutions are right here. So 0 or natural log of 7 should work in that equation. If we store them into our calculator and verify that, they will indeed be their solutions to this. So that's the methods for solving different types of exponential equations. What I'd like you to do is maybe pause this recording now, and if you need to, go back and view bits and pieces for the different methods for the different types of equations. But try these 4 problems, solve them, check them on your calculator, bring them to class with you tomorrow, and then we'll discuss these problems and take a look at practicing some other ones before we move on to our next part of our unit.